So today we are going to talk about solutions. Okay, this is where you're given a equation and they're going to tell you what does this E here equal. And then our job is to find out if it actually is going to work or not. Okay, so that's what our job is to do today. Okay, so I will determine and justify if a number is a solution. That means we can't just say true or false. We have to show whether it is true or false. Okay, what we learned last week and the week before, what we've been reviewing, how to write and evaluate algebraic expressions using positive and negative rational numbers. Okay, we need this because eventually we are going to do what we call two-step equations. Okay, so we're going to start those probably in December. So you see two-step equations over here up in the clouds. Those are what we're going to eventually be getting to. So today's lesson is just working with solutions. So we need to talk about what is a solution. A solution is a number or numbers that makes a statement true. Okay, and they're true for certain reasons. Okay, then we have an illustration of where you have, okay, is it balanced? Okay, that's a real important part of knowing what an equation is. Is it balanced? Okay, so if I was to say x equals 5, that means 5 equals 5. It is still balanced. Okay, you'll hear more about that as we get to actually solving one-step equations. Examples is to say 7 is a solution. Then you're given an equation of x plus 3 equals 10. Like we did with evaluating expressions, replace the variable with its given value, and we find out, hey, 10 equals 10, so that is true. Okay? Our non-examples is where we have 3 is not in a solution. Okay? Using the same x plus 3 equals 10, we replace our variable x with 3, then that 3 plus 3 is 6 is false. That means 6 does not equal 10, as we have learned. Okay, so we're going to do 3 examples in your notes. So hopefully you have these to put together. Okay, so let's scroll down and we'll go ahead and start working these out. Our first one that they gave us is -3, a solution. And they give us the variable m plus a -12 equals 15. So what we need to do is just like with expressions, replace this m here with our -3. So I'm going to take my -3 plus a -12. I'll erase my little boo-boo here. There we go. Now it looks like a 12. Okay. And is that going to equal 15? Normally we want to try to line up our equal signs as much as we can. Okay, well, I have two negatives, and we remember our integer rules of same signs. We're going to add them and keep them because we are decreasing twice. If you borrowed $3 one day and $12 another day, you owe me $15. So then would we say -15 is equal to 15? That is a false. Okay, another thing we like to do is see where the equal sign is. We want to cross it out. They are not equal. Okay, so that's another nice visual when we say it's false, is the not equal symbol. That means they are not equal. Okay, so let's look at another set. Is 5 a solution for 7 plus 4 times w equal to 31? So like I said, we're going to replace w with my 5. And it's not going to make it 45. Remember, that is 4 times 5. And we want to make sure it's equal to 31 to know if this is true or false. Okay, so here I have 7 plus 20 0 equal to 31. Well, what is 7 plus 20? Well, 27. So is 27 equal to 31? No, so this is false as well. Okay, if you need to pause that and then catch back up, go to our third and final one here. Is -4 a solution? Now, sometimes the variables can be on the right side. There is no rule saying it has to be on one certain spot. Okay, so let's plug this in. A -36 equal to -3 times the difference of 8 minus -4. Now remember, we got to put that -4 in there too. Remember, we also then come in and we have to add the opposite. Remember all those integer rules we learned so long ago? We still got to do them. Okay, so let's rewrite it. Still keeping our equal sign lined up to stay nice, neat, and organized. Well, if I have $8 and I earned 4 more dollars, how many dollars have I earned? Well, 12. Okay, so then our only job now is to multiply -3 and +12, and that actually makes a -36. So would we say this is true? Is -36 equal to -36? True. Okay, we know K is equal to our -4. If you need to, pause this and then come back to your video. And we are going to do kind of like a Venn diagram without the circles. We're given x equals 10 for 3x plus 7 equals 24. But then over here we have something different. Instead of equal sign, they gave us a greater than. So what we want to discuss is what is similar about these and what is different. Okay, so the first thing, the one on the left is an equation because of the equal sign. And this one is what we call an inequality. Okay, so if you need to pause this, fill in your Venn diagram. Okay, so now let's actually solve. Well, if I have x equals 10, I'm going to fill it in. Same thing over here, except we have an inequality. So then we have 30 plus 7, and we get 30, 7. Okay, we got me there for a moment. Whereas over here, we kind of have a little bit of a difference. All right, so is 37 equal to 24? No, it is not a solution. It is false. What about, is 37 greater than 24? Yes. So that's where they're different, is that they both are, yes, replacing x, but our solution actually comes out different. But what do they have in common? Okay, so let's I have that they both are using the same terms. 3x, they both have 7, and they both have 24. Those are your three terms. Okay, we are both using x equals 10. We substitute 10 in place of x, just like we do with our expressions. And then we evaluate and we check to see if our solutions are true or not. That's the same thing. That's what an equation and an inequality of these two have in common. And we are going to eventually get to inequalities. Okay, so you need to pause this and then come back. Okay, so here is some homework assignments. Okay, you need to fill in the blanks. Okay, go back and look into your notes. And then we need to check. So let's do a couple of the checks together. And then you're going to come back and finish the rest. Okay, so if x equals 4, 4x plus 3 equals 5. I know in my head it's not going to be equal because I know I have to take 4 plus 5. But we have to justify by showing our work. I know many of my own students in Mrs. Oliver's class have not been showing work and losing points on their quizzes for that. So it's always better late than never. Start showing your work. Replace our variable with the number value. So I put 4 plus 3 equal to 5. That's what we're trying to find out. Okay, well, what is 4 plus 3? 7. A little bit of a sloppy 7. But it is equal to... So is 7 equal to 5? No. So is this a solution or not a solution? Not a solution. Okay. Remember with Kami, you can scroll in and scroll out. Okay, let's look at one of the more difficult ones to talk about. Let's do 9. Okay, it's been a while since we've done fractions, but we need to replace b with this mixed number. So if you need to, scroll in so that you can write neatly. All right, so 1/3 times, I'm going to go ahead and put this as a mixed number with using the Concord C because I know that's eventually what I'm going to need to do. Okay, so we have 5/2 minus 5. And we want to know, is this going to be equal to my -4 and 1/6? Okay. Well, if I multiply across, I get 5/6 minus 5. Is that going to be equal to a -4 and 1/6? Okay. This would be one that you would use your borrowing. Okay. So this is really 5 is really equal to a 4 and 6, 6. And we are going to subtract my 5, 6 from that. Okay. Now, if I was to add the opposite, this would look like a -5. So that means my answer has to be a negative number. And we get a -4/6. Or -4 and 1/6. So is this a solution or not a solution? Solution. Okay, so there is 2 of them checked for you. You need to remember to look out for your negatives. Okay, remember your integer man and your integer rules. Okay, if you need to, go back and look at those notes. Okay, all right, you guys have a great day. Get your assignments done and have a great Thanksgiving week.